Okay, so this question is saying that when 0.15 kg of ice of 0 degree centigrade is mixed with this kg of water at 50 degree centigrade in the container, the resulting temperature is this much. So this is one of the most important part of the question, that resulting temperature is this much. Why this portion is very important? Because we need to see ki from ice to water it is going, or from water to ice it is coming. Okay, we have to focus on that part. So because final temperature or resulting temperature is above 0 degree centigrade, so obviously it will be water, right? Finally it will become water state. So what is happening, this kg 0.15 kg of ice is mixing, right? So for ice what will happen? For ice, it will gain the heat, because from 0 degree centigrade to 6.7 degree centigrade it is going. So heat gained. And how much amount? So we have to focus at first on the state change and on the rising of temperature also. So 0 degree centigrade it was in ice initially. So to go to 6.7 degree centigrade, that means water, it should face a state change from ice to water. That means from 0 degree ice to 0 degree water it will go at first, then it will go to 6.7 degree of water, right? So here delta q is simply m into lf, latent heat of fusion. And here water to water simply means temperature is rising, so m into s water into delta theta. Okay, now heat is lost by whom? Heat is lost by the water. So heat is lost by the water. And for ice, for this much this ice, the mass was how much? 0.15, right? 0.15 in kilogram unit. So let me find out at first the value of heat gained, right? So what is the value? Total value will be sum of these two, means m lf plus m sw into delta theta. This is the value of delta q. And if you put, then m will be common, and lf plus m plus sw into delta theta, right? Delta theta. So basically what is the change in temperature? Lf we need to find out, lf we will find out, but what is what is the specific heat capacity of water? It is given in joule unit. So 4186 into delta theta is how much? Is the change from 0 to 6.7, 0 to 6.7, so it will be 6.7. okay, is the change clear? Now this is the scene, this is the situation where heat is raising. Now the situation is where heat is lost. Who will lose heat? Because the water was at 50 degree centigrade temperature, its temperature is falling to 6.7. Is there any state change? Obviously no, because water is coming to water, no state change. So heat lost is delta q is equals to m into s water into delta theta. Mass is how much? Mass of the water is 0.3 into s of specific heat of water is 4186 into delta theta, means change in temperature. So from 50 degree it is coming to 6.7 na? So 0.3 into 4186 into 50 minus 6.7 will give us 43.3, right? This one. So basically this heat loss will be equals to this one. Okay, and m is known. This m is how much? M of ice, it was 0.15. It was how much? 0.15. So we can write down simply here, it is 0.15. Now if you equate these two, means heat gain is equals to heat lost, then you will easily find out the value of LF. This is the main concept. Now calculation part you can do, right? Calculation part, it will take time, but you can do this part. So I am not interfering on that. Okay, in that portion you can do that one, because you are habituated with the solution of CBSE board exam without calculator, right? So you can do those one. What is the concept? You have to see that what is the final situation. Is it water or is it ice? You have to see at first this one. if let us suppose left hand is ice, right hand is water, final is water. So ice to water, there will be state change. Water to water, no state change. Now if final is ice, then ice to ice, no state change. Water to ice, there will be a state change. So this means after taking assumption like this, you can means go with the this kind of problems, and one of the most easiest problems if this kind of problems are given in your exam. Okay, thank you for watching.